Here is one more example. I would like you to do this by yourself. See the answer on the next slide. What I want you to be able to do is look at each step, know where it came from, uh, and why that step is correct. At this stage, the goal is to understand why a particular proof is correct. Uh, Once you have seen this many times, you will be able to write your own proofs. Writing proofs is generally a challenging task. What we are going to do in this class is fairly simple kind of proofs. So once you have seen a few of them, you should be able to see some pattern to help you write the proofs yourself. Here is the proof from the previous slide. I'm not going to sort of explain each step here. I want you to make sure that you understand why each step is coming the way it is and why it follows from the previous steps. I'm going to add this slide to this presentation, even though it's not exactly related to it, but it's something that would be useful when you're writing some other proofs over the time. And this is something that people have trouble writing, so I want to sort of express this question of what we want to write is we want to show or we want to write a formula that says there is a unique element in our universe of discourse that satisfies the predicate f. Our goal is to write a formula that represents this thing. So the first thing that comes to mind is we can say there exists x f of x. The problem with that is if I say there exists x f of x, that means there's some element that satisfies this property, but there could be more than one. So we want to say that it's not that there is one element. We want to say there is exactly one element in the set that satisfies this property. So it could be an example would be like there is exactly one prime number that is even, something like that. So the simplest way to think about this is using this formula. This says there exists x such that f of x is true, and if I take any y where f of y is true, then y must be equal to x. So that basically says there exists an x where f of x is true. And now, by the way, for any element y in the same universe of discourse, if you happen to find f of y is true, then it must be the case that y is same as x. Now we can take this formula and simplify it, rewrite it using different ways. We can add double negation to this because that doesn't change the value of the formula. We can simplify it by pushing one of the negations in, and there are these different formulas that are essentially equivalent. You can choose whichever makes sense to you, but I want you to see what's going on over here. What I want you to do is now I want you to write the formula that says instead of there is a unique, what if I said there are exactly two? Could you write the formula for that? Now the formula would be a little bit more involved, but you should be able to write it if you can use any one of these formulae to generalize it to the scenario where we want to say there are exactly two elements that satisfy the property. Once again, we have reached the check before you go ahead slide. And the thing that I want you to be able to do at this point is we went over several proofs. I want you to be able to reproduce those proofs on your own, but not in a way where you're memorizing it, but rather understand what's going on in each step and should be able to do that proof. We've reached the end of the module, so please do the review quiz for this module.